The survey, when the figure of the detector does not coincide with that of the user of the survey itself. It must be substantially divided into two phases. The first, which we will call recovery, concerns data acquisition. The second, which is the phase in which the detector communicates the result of the survey to the user, we will call it restitution. A classic case of splitting these two phases is the aerial photogrammetric survey. The plane flies over the territory and photographs it in such a way that, in the longitudinal direction, the frames overlap by 60%, while the lateral overlap of the strips is 30%. Therefore, a certain skill of both the pilot and the navigator is needed, who directs the operations. Already in this case, the focal point of the camera returns. Normally, when commissioning an aerial photogrammetric survey, we limit ourselves to saying a survey at 500, at 1000, at 10,000, etc. But, perhaps, no designer, and no urban planner, commissioned the survey with an indication on the focal length of the camera. Apart from the discussion that there would also be to choose the sensitive material, which can be black, white, or color, or infrared. And it is clear that if you only request the classic graphic return, there will be no firm that will make a color relief. While, if the urbanist used stereometric pairs of frames, he would understand very well that color photography gives more information than a black and white one. Even when you only need the survey with contour lines. Those who shoot, use, not only black and white material, but black and white material with low sensitivity, for greater contrast and more sharpness in the images. Here we see an example of how, with the same focal length, by changing the flight altitude, the surface taken changes. But we must not forget that we cannot resume the same area of land, varying the altitude and consequently varying the focal length of the lens. Another detail to keep in mind, in the aerial photogrammetric survey, is the base of recovery according to the altitude. In the diagram, used here to give us the mathematical formula with which to derive the height of the building, we note with can be unpacked an aerial shot. In the pair of frames, schematized in this drawing, we immediately see that one frame captures the house from above and the other frame photographs the house alongside. Basically, whoever observes this pair of frames with the stereoscope, he sees, with one eye, the roof of the house, and with the other eye, he sees the whole side facade. And this creates at least a nuisance, and materialize in a poor vision of the three-dimensional optical model and imprecision in the restitution. Clearly these are expensive machines. Here we see one of the wild hybrid that used 23 cm wide films, or rather, they used films, because now, with the arrival from digital cameras, they should be updated. The frames were 23 by 23 cm in size, with all the problems related to the flatness of the frame. In fact, slabs were originally used. With the use of the film, at the moment the shot, it was glued to the support, creating a depression behind it. It stuck to the flat support, which was equipped with holes. The high costs of the lenses usually leads the company, if it does not have a great chance to use only one lens. The most common lens has a focal length of 153 mm and 153 mm on 23 cm is almost a wide angle. And take a shot at low altitude with a wide angle leads to those drawbacks that we have seen in the diagram. So let's go back to underlining the lens focal problem. We have to realize what the consequences are. Clearly, with a satellite shot, the last ones maybe change. But even in that sector there is a whole basic discourse of shooting, etc. etc. Plus image processing, which also has its reverse.